Hi, I'm Professor Goins and welcome to the Math Professor's YouTube channel. If you're looking for videos explaining topics in college mathematics, you're in the right spot, so go ahead and hit the subscribe button. That said, let's get into the current video. I'm going to talk about how to find the domain of a composition of functions. In other videos, I talk about how to evaluate compositions, how to simplify compositions. In this one, I'm going to look at a composition of functions where we then have to find the corresponding domain of that combination. First and foremost, let me remind you of the definition of the composition of functions. The composition of f of x and g of x is given by the following. So the notation between the two function names, I'm going to use this little circle, okay, that stands for the composition operation. And the way that we apply this operation is I use the function that's listed on the right as an input, which gets plugged into the function on the left. That means I write this as f evaluated at g of x. Okay. Now if I was to plug in a specific x value, let's kind of look and see what happens to that x value. The first thing that I do is I evaluated the function g, then that as an output is going to be my input for the function f. Okay. So we've got a couple of different things here for the domain. If I'm going to plug a number in to this composition, first and foremost, it has to be in the domain of g, right? If the number is not in the domain of g, it can't go into the composition because it goes into g first. Then the function value, say g of 4, whatever number I plug in, if I plug 4 in, for example, g of 4 would then have to also be in the domain of f. So we've got two different functions that we have to look at the domain of, and so there's some details there that we're going to go through. Okay, so let me go ahead and remind you of how we find the domain of a function. So, and this is sort of like in a sort of a pre-calculus or algebra calculus course, something along those lines. So to find the domain of a function. Actually, that one is running out of ink, so let me go ahead and get a different color going here. To find the domain of a function. Now, there's really two different scenarios in your, I'm just going to call it an algebra course. It could be calculus, it could be pre-calc, whatever the case may be, something along those lines. There's really two different scenarios where you're going to find the domain of a function. One, if I'm given a graph, and the other one is if I give you a function expression. So let me kind of illustrate both. If I give you a graph, let's say it looks something like this, and if I give you a function expression, maybe it looks something like this. Okay. Now, in the right-hand example, so where this is a function, say f of x, to find the domain, I actually look for what x values am I actually using. So let's say, let me just kind of make up some numbers here. Let's say this goes back to -2 and this goes over to 7. I would see how far does the graph go to the left, how far does the graph go to the right, and it looks like it would go from -2 to 7, and I'll go ahead and write that in interval notation. Now, with a graph, again, I'm looking for which x values am I specifically using. When I give you a function expression, I'm doing the opposite. I'm actually looking for which x values can I not use. And we base this on restrictions. Like I can't have denominators of 0. I can't have negatives under a square root. Again, until you take more advanced courses and you introduce complex numbers or use complex valued functions. Even if you introduce complex numbers in your algebra course, you're probably not using complex valued functions. Anyway, so I can't have negatives under square roots or even index radicals, and I can't have zeros and denominators. And zeros and denominators is probably the main thing that you're going to be concerned with in your course. The only thing I can't use here is 3, so therefore it would be everything to the left of 3 and then everything to the right of 3. And this right here is the main thing that we are going to look at in finding domain of a composition, because I'm going to give you the function expressions. So let me go ahead and work through an example to illustrate the concept of how to find the domain of a function composition. So let me give you two functions. Let's say f of x is equal to, let's do x plus 1 over x minus 3. And let's say g of x is given by, let's do x squared minus x squared minus 1. Okay. Find the domain of f composed with g. So solution. Again, if I'm going to evaluate the composition, so if you haven't, again, I'm assuming you know how to evaluate compositions. If you're not familiar with that, please go watch that video. But if I'm going to find the domain of a composition, the first thing I have to look at is, let's kind of trace through if I'm evaluating this. If I plug a number in for x, it first has to go in for g. So what I first have to do is, 1, identify any values which cannot be evaluated with the function g. And again, this just means the first function. If this was g composed with f, you would replace this with f. It's just the first function that I'm plugging in. Anything that I would plug into g that would give me, say, an undefined value, dividing by 0 or something, I have to eliminate from the domain of the composition. 2, remember that after I evaluate g of x, that output is then going to get plugged into f. So the idea is I also have to identify, and let me just phrase it this way, invalid inputs for f of x, or in general, just the function that's on the left here. Say, for example, x is equal to a. So let's say whatever number is, whatever number I can't plug into the function f. In particular, we know that I can't plug 3 into this. The idea is I have to say, well, when would g of x equal 3? If g of x is ever equal to 3, then I have to eliminate those from the domain as well. So let me go ahead and write out sort of the third step here before we get into the details for this specific example. So the third step would be solve the equation g of x is equal to a for every invalid input x equal to a for f of x. Because remember, let's say I could plug in, let me just make up a random number here. Let's say I cannot plug 7 into the function f. But I can plug the number 2 into the function g. But let's say g of 2 was 7. Well, then I can't plug that number into the composition, because tracing through that number 2 would turn into a 7, which would be the output for g, but then that can't be used for an input for f. So I would have to eliminate for that from the domain of the composition. Let's go through then with, actually, and then step 4, this is just my conclusion. The invalid inputs for f composed with g. And as a reminder, invalid inputs is just a number that I can't plug in because I get, say, an undefined value. The invalid inputs for f composed with g consists of all values from steps 1 and 3. If I can't plug it into G, then it's eliminated from the domain of the composition. If there's a number that I can't plug into F, and there's something that generates that function value through G, then I also have to eliminate from the domain. Okay, let's go ahead then and work out the details for this specific example. So if I want to kind of follow along with the steps here, I'll kind of label it as step 1. Identify any values which cannot be evaluated with G. So the function g of x is actually a quadratic polynomial, and I can plug in anything to that. So what I could just do is, just for a shorthand, I'll just use the symbol for the empty set. There's no values that I cannot plug into G. 2. Identify invalid inputs for the function f of x, and go to my function f of x. What can I not plug into this? Well, I know that I cannot plug in x equal to 3. So I'm going to say x is equal to 3. Again, just as a shorthand, matching it up with the step here, this step 2 is the invalid input for the function f of x. Now let's go to step 3. Solve the equation g of x is equal to a for every invalid input of f. Therefore, for step 3, what I'm going to do is I'm going to take the function g of x and I'm going to set that equal to 3. If I had, say, 3 comma 5, I would solve g of x equals 3 and also g of x equals 5. So whatever invalid inputs are listed here, I'm going to set up an equation for step 3 where that invalid input is equal to g of x. Now let's go ahead and solve this equation. X squared minus 1 is equal to 3, right? Quadratic equation. I can add 1 to the other side. X squared is equal to 4, and that gives me x is equal to plus or minus 2 for the solutions to that equation. Now for step 4, conclusion. The invalid inputs for the composition consists of all values from steps 1 and 3. From step 1, I had no invalid inputs. From step 3, I have plus and minus 2. So therefore, the domain of the composition, so let me clean this up and I'll write it over here. For this specific example, the domain of f composed with g is everything to the left of negative 2, everything between negative 2 and 2, and then also everything to the right of 2. Again, notice if I was to take the number, say, positive 2, and I plug that into the function g of x, I would have gotten 2 squared minus 1, which is 3, which is a completely fine function value. However, that cannot be plugged into the function f, so it must be excluded from the domain. Let me do one more example. Let's say f of x is 2x minus 1 over x minus 2, and let's say g of x is 4x divided by x minus 1, and then find, just for a shorthand, find the domain of f composed with g. Okay. Notice that both f and g are going to have restrictions in this case, and let's see how this works out. So, solution. I'll write the step number, so corresponding to the procedure that I had in the previous example. I'm not going to write out, that was way too much to write again, but I'm just going to kind of write the step number and then the information corresponding to that. Okay, so step number 1 was to identify any invalid inputs for the first function. In other words, I can't plug in the number 1. So I know that x equal to 1 would be an invalid input for the function g. And then for step 2, I have to identify any invalid inputs for the function f. Well, for the invalid function values for f, notice I can't plug in 2. So this would be x is equal to 2. So again, just as let me put this up here as a reminder. This is, let me get a different one. This is invalid for g of x. This was invalid for f of x. And then step 3 was to say when will I ever get, if ever, but when would I ever get an output for g which would generate the invalid input for f? In other words, could the function value g of x ever be 2? So for step 3, I'm going to solve g of x is equal to 2. Okay, because remember, after I plug a number into g, that output then gets plugged into f. So if g of x ever has an output 2, that original number can't get plugged into g. Well, let's go ahead and solve this. I get 4x over x minus 1 is equal to 2. And we can clear the denominator to solve this. So 4x is equal to 2 times x minus 1. 4x equals 2x minus 2. So then I go ahead and add 2x over, so I get 2x is equal to negative 2, and therefore I get x is equal to negative 1 for the solution to g of x is equal to 2. Now step 4 was to say the domain of the composition is all the values from step 1 and 2. So I want to do one other thing with this number negative 1. We're going to verify that this is an invalid input, but let me just go ahead and write the conclusion first of all. The domain of f composed with g consists of everything excluding the numbers from steps 1 and 3. So that means this would be everything to the left of negative 1, everything between negative 1 and 1, and then everything to the right of the number 1. So in interval notation, that will be my domain of the composition. Now, when we go back to the original functions here, we can clearly see that I can't plug the number 1 in, and we see that there's an issue with the number 2, again, for the composition. Now, just eyeballing it, we don't see anywhere where the number negative 1 is a problem. Okay? But going through this procedure, I came up with negative 1 was a value that I cannot plug in. Well, let's go ahead and verify that. So let's verify negative 1 is invalid for the composition f composed of g. Okay. So what that means is I'm going to evaluate f composed with g of negative 1. Let's see what happens. Remember that the function or the input value gets plugged into g first, and negative 1, plug that into g, I'm going to get 4 times negative 1 over negative 1 minus 1, so negative 1 minus 1, which is f composed with, on top I'm going to get negative 4, on the bottom I get negative 2, which of course is 2, so I get f of 2, but we know that 2 cannot be plugged into the function f. Since 2 cannot get plugged into the function f, if I trace back to the beginning of this computation where I started by plugging in -1 into this combination, the composition F composed with G, led to that invalid input. So therefore, -1 is actually invalid for F composed with G, verifying that this is my domain. Okay. Thank you for watching, and please consider subscribing.